Hello everybody. In today's lesson we're going to be learning how to draw and name alkanes, which are hydrocarbons that only contain single bonds between the carbon molecules. Here, this is going to take a minute, so forgive me. This might be a little bit of a long video, but we need some background. For hydrocarbons, and we're talking only about straight and branched chains today, there are two parts, the backbone and the branches. And they have very similar rules, but a little bit different. The backbone is the longest continuous chain of carbons you can find in the molecule. When you're looking for this, what I recommend that you do is just put your pen down onto a carbon at the ends of a chain, and then draw the longest line you can make without retracing or without picking up your pen. So let's just take a look here. Here's a molecule, and we want to try to find the backbone. So in a picture like this, the ends and the angles are carbon molecules, carbon atoms. And so we need to find the longest chain we can make. So let's just start here and start counting. 1, 2, 3, 4, 5, 6. So this chain here is 6 long. 1, 2, 3, 4, 5, 6, 7. Here's 7. Since 7 is longer than 6, this is looking more like the backbone, but let's confirm. 1, 2, 3, 4, 5, 6, 7. So these are equally long. And then 1, 2, 3, 4, 5, 6, 7, 8. Since 8 is the longest chain we can make, I know that this backbone is 8 long, and the prefix for 8 is oct. And when you are naming a backbone, when there's only single bonds, it's going to end in ane, A-N-E, and this is going to be the last part of the name. So, since this is 8, it's oct, and the backbone ends in ane, A-N-E. And when we name this, the backbone is going to be the last part of the name. Now we need to consider branches. Branches on alkanes are the carbons that come off of the backbone but are not part of it. And when you name branches, there are 3 things you need to keep in mind. The origin of the branch must be indicated with a number. And the origin is just what number carbon did that branch come out of. And you want to choose a numbering system such that the first branch you encounter has the lowest number you can make it. And we'll see a lot of examples of this. Second rule is that branches are named in alphabetical order. So F comes before meth, meth comes before prop, but comes before eth, and so on. It doesn't matter what number it is that it comes out of. It matters about the alphabetical order. Then finally, if there are identical branches that appear multiple times, then we give them a prefix, di, tri, tetra, etc. And something to note is that these prefixes do not affect the alphabetical order. So, dibutyl is still ahead of ethyl, okay? Or tributyl is still ahead of ethyl. It only matters about these prefixes. It doesn't matter about these ones. And the branch names always come before the backbone names, and they end in ul instead of ane. So let's take a look at this molecule here and see if we can follow all these rules. We want to start numbering this backbone. I'll highlight it. Right. we want to start numbering this such that the first branch has the lowest number possible. So if we call this 1, 2, 3, 4, the first branch is going to be coming out of carbon 4. If we call this branch 1, then if we call this side 1, then the first branch will be coming out of carbon 3, and 3 is lower than 4, which means this is carbon 1. And then we can just number the rest in the backbone. And when we're naming this, we're going to figure out what these branches are first, because they have to go in alphabetical order. Coming out of the 3 is a methyl branch. And I know it's a methyl because there's only one end. There are no angles. Out of the 4 and 5, there are 2 carbons, and so these are both F. And E comes before M, so I'm going to put the F branches first in the name. And the first thing I'm going to do is indicate their origin. They're coming out of 4 and 5, and since they're branches, they're going to get that ul ending. Now here, we actually forgot something. And this is really easy to forget about, especially when you're using multiple numbers. But we need to be including these because these branches are identical. They're both F. So we're going to have to edit this. And it becomes diethyl, di for 2. And then finally 3 methyl. Okay, and I'm sorry for this. I'll write it again so it's clearer. 4, 5 diethyl 3 methyl octane. Okay, this is the system, and I'll leave this here so you can pause and you can read, but we're going to do a few problems right now. Okay. So if you see something like this, this is a different type of drawing, but it follows the same rules. And in this case, you don't need to know about angles and ends. You just need to think about C's. And when you're counting them, okay, the backbone does not have to be straight. It just has to be the longest chain you can make. So the longest chain we can make here is 4 carbons long. So I know that somewhere in this name, there's going to be butane. Now I have to decide on counting. Is this one or is this one? And we make a decision based on which position for 1 will result in the branch having the lowest number. If we start here, the branch comes out of 2. If we start here, the branch comes out of 3. And so we start here. And what's coming out of this 2? Well, 1 carbon, which is meth. So this is 2 methyl butane. Okay, let's keep going. For this one, find the longest chain you can find. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So the longest chain here is 7 long. 7 is hept. So this will be heptane. And when we start counting here, you're going to notice that you have options. Because no matter where we start, 1, 2, 3, the branch will be coming out of 4. And that branch is 2 carbons long, which is F. So when we name this 4-ethyl heptane. Let's do a few more. With this one, again, let's try to find the longest chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. The longest chain looks like it's going to be 7. And since there are 2 of them with 7, we have options. We can choose whichever one we'd like. Let's just choose the straight one. So again, this will be a heptane. And now we have to decide which is 1. I'll give you guys a second to think, and then I'll come back. If you pick this one, you are correct, because that means the first branch happens at 3 as opposed to 4. And what's coming out of the 3? 2 carbons, that's F. What's coming out of the 4? 1 carbon, which is meth. And I need to make a decision about the alphabet. E comes before M, and so F will be named first. 3-ethyl, 4-methyl heptane. Okay. Let's just do a few more practice ones. The longest chain, you can trust me here, is 8. And now we start thinking about where's 1. If this is 1, first branch is 3. If this is 1, first branch is 4, which means this is 1. Now we have a methyl group, and here there are 3 carbons, which is propyl. M comes before P in the alphabet, so this branch will be named first. And we get 3-methyl 5-propyl octane. For this last one here, I've had some debate with my students. I think there are 2 different answers here, and I'll put both. If your teacher says there's one that's better, listen to them and go with them. But the longest chain is here. It's 7 long, and no matter where you start numbering, the first branch will be 3. And because of this, I believe you have options. You can call this one, or you can call this one, but you need to pick. I'm going to pick this because I read left to right as an English speaker, but that's just purely a stylistic choice. You could start here. And we have meth, 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 3 identical branches. And when we name this, it'll be 3, 3, 5, tri, because there are 3 identical branches, and those branches are methyl, and the backbone is heptane. Now here's where the debate comes in. I believe that 3, 5, 5 is equally valid if you started numbering from the other side. Some people have said that all branches should have the minimum number possible. Some people say that the first branch should have the minimum number possible. I don't really think it matters. If your teacher cares, do whatever they tell you to do. Now this, I actually believe, is the more difficult way to go from drawing to name. To go from name to drawing, I hope you will find, is actually a lot easier, but let's do a few examples together. When you encounter a name, the first thing you should do is go to the very end, because the end tells you the backbone. And this backbone is hept, which is 7 carbons long. So let's make a backbone 7 carbons long. Remember, ends and corners or angles are carbons. So 1, 2, 3, 4, 5, 6, 7. There's the backbone. It's 7 long. Now we keep going backwards in the name, and we see meth, right, which is a branch 1 carbon long. The die tells me there are 2 meths, right, times 2, and then these numbers just tell us where they originate from. And when you have a name, you have a choice if you want to read left to right or right to left. Again, I'm going to choose left to right every time, which means this is 2, this is 3, and there are my meth branches. For this example, we're going to repeat the same process. Start at the end and draw the backbone. Oct is 8. So we have a backbone 1, 2, 3, 4, 5, 6, 7, 8 carbons long. And let's keep going back. Prop means 3. So there's a 3 carbon long chain originating from carbon 3 in the chain. 1, 2, 3, 1, 2, 3. Keep going backwards, we see meth, which is 1 carbon long, and it's originating from the 4th carbon in the backbone. Meth. Number 3 is also an octane, so we know how long it is. 1, 2, 3, 4, 5, 6, 7, 8. It has 1 branch, which is an ethyl. Eth is 2 carbons long, and this branch is originating from the 4th carbon in the chain. 1, 2, 3, 4. Eth is 2, 1, 2. Now the last one we're going to do today, this one here. Start at the end. Pent is 5. And let's make a backbone that's 5 long. 1, 2, 3, 4, 5. Then keep going back. Meth. Methyl branches are 1 carbon long. This die tells me that there are 2 of them, and they're both originating from the 3rd carbon. So, 1, 2, 3, meth, meth. Before I end the video, I want to zoom in on this guy because I get a lot of questions from my students. Does it have to look like this? No, it doesn't. I really don't care how you draw it. All that needs to be true is you need to follow the naming conventions. You need to have 2 methyl groups coming out of the 3rd carbon. And so you can draw it like this. There's nothing wrong with that drawing in my class. All you need, 3rd carbon, and you need 2 1 carbon long chains coming out of it. Right? This and this both satisfy the name. This type of work is going to take practice, and you're going to have to do just problem after problem for it to make sense, but it's all in the name. I'm going to show you the rules one more time. Feel free to pause the video, take a picture of this, and practice on your own. Good luck, and I'll see you in the next video.